Hi, so this video will cover progressions and worded problems. The first topic for this video is arithmetic progressions. But before that, let's define first what a sequence is. So a sequence is a set of numbers with a definite order of arrangement and formed according to a definite rule. The numbers in a given sequence are called terms. So basically, these are a set of numbers with a definite order with some sort of pattern going on. Alright, so let's delve into arithmetic progression. Arithmetic progression is a sequence of numbers in which each term after the first is obtained by adding a fixed number to the preceding term called common difference. So examples of arithmetic progressions or APs are, let's see. So you have 1, 6, 11, and 16 with a common difference. How do you solve for the common difference? So the common difference, you're just going to subtract the preceding term from the term after it. So in this case, let's see, 6 minus 1 is 5. 11 minus 6 is 5. And 16 minus 11 is 5. So that's their common difference. Um, the terms for the arithmetic progression can be seen in this table. So this would be your first term, your second term, your third term, and so on and so forth, until whatever number of terms you want to reach. So A1 would stand for your first term, A2 would stand for your second term, and AN would stand for your nth term. Now, to solve for the pattern in which you would get the terms in an arithmetic progression would be you're going to add the common difference to your terms. So in example, in this one, so you have your first term, you're just going to add your common difference so that you'll get your second term. And then for the third term, you're going to add twice the common difference to your first term to get to the third term, or you're going to add the common difference D to your second term, and so on and so forth. So, yun yung pattern natin. Now, to get the common difference, as I said earlier, you're just going to subtract the preceding term to the term after it. So that's, you're going to subtract A1 to your A2 or A2 from your A3. Alright? So to solve for the nth term of an arithmetic progression, this is our formula. So the nth term of our AP would be equal to your first term plus the number of terms minus 1 multiplied by the common denominator. And then to compute for the sum of the nth terms of an AP, you're going to use this formula. So it is the number of terms n divided by 2 times A1 plus the last term of your series. Or you could use this formula. So n divided by 2, quantity 2 times A1 plus n minus 1 times the common difference D. Alright, so let's solve some examples. So example number 1, we are to find the 30th term of the arithmetic progression 10, 7, 4, and so on and so forth. So the way we solve this, first let's check what is given. So let's write down our given. So we have our first term A1, that's 10. And we're interested in the 30th term, right? So from our equation here, so we're trying to figure out the 30th term of our arithmetic progression, right? So from our given, we have A1, we have N, but we don't have D. So first, let's solve for D. So our D, to solve for D, we're just going to subtract the preceding term to our successive term. So in this case, let's say 7 minus 10. And that is negative 3. So that's our common difference, right? So we can now use this formula to solve for the 30th term. So we have A30, A sub 30 is equal to A1, which is 10, plus N, which is 30, minus 1, times the common difference, negative 3. So solving that, we get our A30 would now be negative 77. Alright, so that's our final answer for the first example. Right, so second problem. Which term of the sequence 4, 7, 10 is 52? So again, let's determine what's given in our problem. So we know the first term, A1, which is 4. We know the nth term, which is 52. We don't know the common difference, but we could solve for it. So that's just D is equal to 7 minus 4. So that's just 3. Alright, so I think we could use this formula. So we have the nth term, we have A1, we have D. What we're trying to figure out is N, the nth term, or what number of term is 52, right? So let's just substitute the values in our formula. So AN now is 52. That's equal to A1, which is 4, plus N minus 1 times 3. So solving for N now would be equal to 17. So 52 is the 17th term in our arithmetic progression. And that's your final answer for our second example. Now on to our third example. We are to find the value of k so that 8k plus 4, 6k minus 2, and 2k minus 7 will form an equation. Alright, so in this problem, what we're going to do is we're going to use the formula for the common difference. So how? So we have here 3 terms, right? So what we can do is we could actually, so the common difference would be equal to A2 minus A1, right? And it would be equal to A3 minus A2, right? So we could now substitute lang natin yung ating what's in the problem, these terms, to our equation. So the second term, which is 6k minus 2 minus A1, which is 8k plus 4, is equal to the third term, which is 2k minus 7 minus the second term, which again is 6k minus 2. Then from this equation, we can now solve for our k. So from this, our k would be equal to 1/2. And that's the final answer for the third problem. Alright, so example number 4. An arithmetic series contains 17 terms. If the first term is 2 and the sum is negative 170, what is the common difference? So alright, again, let's write down what's given. So given. So we get how many terms? 17 terms. We have the first term, which is 2. And we have the sum, which is negative 170. So from our formulas right here, so what we could actually use is this formula, right? Because we have S, we have N, we have A1. And we're trying to look for the common difference. Right, so we're just going to substitute our values to our equation. So S is negative 170, and that is equal to n over 2, which is 17, divided by 2, multiplied by 2 times A1, which is 2, plus n, which is 17, minus 1, times the common difference D. So you get one equation, one unknown. You're just going to solve for D, and it will be negative 24 over 16. Or, simplifying that, negative 3 over 2. And that is the final answer for example number 4. Alright, now on to harmonic progressions and geometric progressions. Alright, so harmonic progressions, or HP, is a sequence of numbers in which their reciprocals form an arithmetic progression. So what we're actually be using here is the set of formulas that we use in arithmetic progression. But first, you need to invert your harmonic progressions, which is this one, before you could use the formulas from the arithmetic progression series. Alright? So let's solve first an example for harmonic progressions before we proceed with geometric progressions. So example number 1, we are to find the 4th and 8th term of the series 6, 4, 3, and so on and so forth. Now to check if this is an arithmetic progression, you're just going to compute for the common difference. So you have 4 minus 6, which is negative 2, and then you have 3 minus 4, which is negative 1. So they don't have a common difference. But if you use the reciprocal of these terms, which is 1 over 6, 1 over 4, and 1 over 3, and solve for the common difference. So that's 1 over 4 minus 1 over 6, and that is equal to 1 over 12. And you check the other one, which is 1 over 3 minus 1 over 4, which again is 1 over 12. So they do have a common difference. So this is a harmonic progression. Now we're going to use the formulas that we used in arithmetic progressions, specifically solving for the nth term of your AP, which is this one. An, or the nth term, is equal to the first term plus n minus 1 times d, right? But when you're using this for harmonic progressions, you're going to use the reciprocals. So here you have an, which is a4, and that is equals to a1, which is 1 over 6, plus n, which is 4, minus 1 times the common difference, which is 1 over 12. Now our a4 would now be 5 over 12. But for this problem, since we're using, since this is a harmonic progression, this is the reciprocal, the arithmetic equivalent of your harmonic series or harmonic progression. So the 4th term is actually the reciprocal, which is 12 over 5. So that's the first part of our problem. Now for the second part, which is the 8th term, so you have a sub 8 is equals to the first term again, 1 over 6, plus 8 minus 1 times 1 over 12. And then solving for the 8th term, it's 3 over 4. So convert natin siya. We will just get the reciprocal of this one. So the 8th term is just 4 over 3. And that's the final answer for the part 2 of our first example. Alright, so on to our geometric progressions. Geometric progressions, or GP, is a sequence of numbers in which any two adjacent terms has a common ratio R. So the common ratio R could be computed by getting the ratio of the succeeding term to the term directly preceding it, or in this case, A2 over A1, or A5 over A4, or A3 over A2, so on and so forth, while our R will be greater than 1, right? So as you can see here, this is our pattern. So what we have here is our first term. For the second term, we're just going to multiply it by our common ratio R. And then for the third term, we're going to multiply it by twice, or R raised to 2, and so on and so forth. Now for the nth term of our geometric progression, we're going to use this formula. An is equal to A1 times R raised to n minus 1. And for the sum of n terms of a geometric progression where R is not equal to 1, we're going to use these two formulas. So Sn is equals to A1 times 1 minus R raised to n all over 1 minus R, or Sn is equals to A1 minus R times An divided by 1 minus R. Alright, so let's try and solve some problems. So example number 2, if the sum of the first 7 terms of a geometric sequence is 547 and the common ratio is -3, find the first term of the sequence. So from this, let's write down our given. So the given is we have the sum of the first 7 terms. So we have S7 is equals to 547. And we have the common ratio, which is -3. Now we're to find the first term of the sequence. So from that given, what we're going to use here, also, our n is 7. So it came from this statement. So the first 7 terms, so we have 7 terms with the sum of 547. Alright. So we're going to use this formula. So we could use this one or this one to solve this problem. For this one, we're going to use this one. I think it's, let's try the first formula. So Sn would now be 547 is equals to A1. So A1 is what we're looking for, times 1 minus R, which is -3, raised to n, which is 7. So let me just fix our separators. Let's use a bracket for this one. Alright. All over 1 minus R, which is -3. Alright. So we can now solve for our A1. So from this equation, our A1 would be equals to 32. So that is the first term of our sequence. Alright. So on to example number 3. The length of the path of the first swing of the bob of a pendulum is 0.6 inch. Each succeeding swing is only 0.9 as long as the preceding one. How far will the bob travel in the first 6 swings? Alright. So from the problem, it says that, let's visualize this first. So we have our pendulum here, and it will swing out like this. And from the problem, it says that the first swing of the bob of the pendulum is 0.6 inch, right? So this is 0.6 inch, or n, yeah, 0.6 inch. And then the next statement, each succeeding swing is only 0.9 as long as the preceding one. So the next swing, the second swing, would probably be 0.6, or would be 0.6 inch times 0.9. So that's our pattern. So from that, what would be our given? So we have the first term, which is 0.6, right? And then what else do we have? We have the ratio, which is 0.9. And then from the problem, what we're interested in is the first 6 swings. So our n would now be equal to 6. And we're trying to look for a, or rather, we're trying to look for the sum of the first 6 swings. So again, we're going to use this two formulas. For this one, we could use this one. So our Sn, we're trying to look for the sum of the 6 terms, the first 6 swings, or S sub 6. So our first term, which is 0.6, minus R, which is 0.9, times An, which is something that we don't actually know. So we can, I guess we can't use that formula. So rather, let's use the first formula. So we have A1, which is 0.6 times 1 minus R, which is 0.9, raised to N, which is 6, all over 1 minus 0.9. Alright? So solving for the sum of the first 6 terms, it would be equal to 2.811 inch. Alright, so that's the final answer for example number 3. The next section of our video is dedicated to word problems. This section aims to discuss categorically the principles embodied in each type of word problem. So here we're going to encounter different types of word problems. The second goal of this is that for you to analyze and solve word problems in practical situations. And lastly, to synthesize all mathematical presentation of problems. Now, the general procedure for solving word problems is done by expressing the conditions of the problems in algebraic conditions. While there is no definite rule that can be followed for solving these problems, but the following strategy listed here will help in the translation of word problems into mathematical symbols. So the first step in our strategy is that first, we are to read carefully the problems until the conditions are all clear. Then determine the given and set what is to be found. Second step is to draw the figures or diagrams and label the known and unknown quantities. Third step, use the formulas connecting the known quantities to the unknown quantities. The fourth step, represent the unknown quantities by a variable, say x, and try to represent all other known quantities in terms of x. Fifth step, form an equation of the translated condition of the problem by relating the known and unknown quantities. 6. Solve the unknown from the form equation. And lastly, check the solution with the condition of the problem. Alright. So the first word problem we're going to tackle is number relation problems. So we're going to do this by solving some problems. So example number 1. The sum of two numbers is 36. If the larger number is divided by the smaller number, the quotient is 2 and the remainder is 3. Now we are to find those numbers, the larger number and the smaller number. Now from equation number 1, the sum of two numbers is 36. So we're going to let x be equals our larger number, while 36 minus x would be our smaller number. So we got this from the first statement. The sum of two numbers is 36. Now from the second statement, if the larger number is divided by the smaller number or the small number, the quotient would be 2 and the remainder is 3. So let's write down that mathematical relationship. So the larger number is divided by the small number. So that would be x divided by 36 minus x. And the quotient would be 2 with the remainder of 3. So that would be 2 plus 3 divided by 36 minus x. Now solving for x, it would now be equal to 25. Now from our first statement, x is our larger number. So for our final answers, larger number is now equals to 25. And the small number would now be equal to 36 minus 25, which is 11. So that is our final answers for the first example. Alright, so on to the second example. When 3 is multiplied by 5 less than a number, the result is 9 less than 5 times a number. Now we are to find that number. Alright, so here we are going to let x be our required number. So this is our required number. And from the statement, when 3 is multiplied by 5 less than a number, the result is 9 less than 5 times a number. So we're going to write down that mathematical relationship. So 3 multiplied by 5 less than a number. So x minus 5. The result is 9 less pala. Okay. So 9 less than 5 times the number. So that's negative 9 less than 5 times the number. So that is 5 times x. Now we are to find x, our required number. So solving for x, we get negative 3. Alright, so that's our final answer or our second example. So our next word problem or our next type of word problem is investment problems. Although we're going to tackle this again when we go to engineering economics, but let's try some basic investment problems first. So, on to definition of terms before we proceed. So, an interest is the money paid for the use of money called a principal. In general, interest is determined by the product of 3 factors: the principal, the rate, and the time. So the principal is the sum of money invested that bears interest, and the rate is the fraction of the principal paid for its use during a certain period of time, usually 1 year. Time is the interval during which the principal is used, and amount is the sum of the principal and interest. Right. So let's try and solve some problems. So Cheska has 6,000 pesos invested at 5% and 6%. Now, how many pesos would she have to invest at 6% so that her total interest per year would be equal to 320 pesos. Alright, solving this problem, we're going to let X be the amount invested at 5%. And 6,000 minus X would be the amount, right? Amount invested at 6%. Now, the interest for each investment are, let's say, so the interest at 5% plus the interest at 6% would be equal to 320 pesos, right? So that is from our second statement. Excuse me. So we could rewrite this in terms of our amounts invested. So let's say X, the amount invested at 5%, times 0.5 plus the amount invested at 6%, which is 6,000 minus X, and it is invested at 6%, so that's 0.06. And it would be equal to 320. Now we can solve for X. So solving for X, we would get 4,000 pesos. So that's in peso. So the amount invested at 5% would be, let me write it down first. Amount invested at, so let's copy this. So at 5% and at 6%. So at 5%, we have 4,000 pesos. And then at 6%, we have 6,000 minus 4,000. We have 2,000 pesos. Alright, so that's our final answers for the first example. Now on to the second example. John invested part of 35,000 pesos in a stock paying 9% interest for 2 years and the balance in a stock paying 6 interest for 4 years. It turns out that the two investments earned equal interest. Now, how much was invested at each rate and what is the total interest earned? So there are two parts in this problem. The first part, we are to determine how much was invested at each rate. And the second part is that we are to find the total interest earned. So let's solve first the first part. So for the first part, we are going to let X be the amount invested at 9%. Amount invested at 9%. And 35,000 minus X would be the amount invested at 6%. At 6%. Alright. Now, the interest earned at 9% is equal to the interest earned at 9%. So, we could write that down. So, we have here I at 9% is just equals to I at 6%. Right? So, we could rewrite that as, so the amount invested at 9%, which is X, multiplied by 9%, so we have 0.09 for the interest, times 2, and that is equals to the amount invested at 6%, which is 35,000 minus X, and it is earning an interest rate of 6%, which is 0.06, and we're going to multiply that by 4. So 2 here represents the 2 years that it was invested for, and the 4 here represents the 4 years it was invested, right? So from this equation, you can now solve for our x. Alright, so solving for x, we'd get 20,000. So the amount invested at 9% is 20,000. So let me just copy this. Wait lang. Copy. And then the amount invested at 6%. Let me copy that as well. So at 9%, it is 20,000 pesos. And at 6%, it is 35,000 minus 20,000. So that's, or rather 35,000 minus 20,000. So we get 15,000 pesos. Right. Now for the second part, what is the total interest earned? So for part, let's see, part B. Oh wait, let's highlight this first. So this is our final answers. So for part B, the total interest earned, let's say, let T be our interest earned at 9%. Interest earned at 9% plus the interest earned earned at 6%. Right. So we could rewrite this as 2 times, so the invested amount, which is 20,000, times the interest, which is 0.9, times 2. And we multiply the whole thing by 2, since this one is supposedly equal. So assuming this is the interest earned by the 9% amount, so this one is equal to the interest earned at 6%. So you're just going to multiply that by 2. And that would be equal to, we can now solve for t, that would be equal to 7,000, 7,200 pesos. Alright, so that's our final answer for part 2 of our second example. Alright, so on to the next 2 types of word problems. So we have here coin problems and mixture problems. Now, the nature of solving coin problems is actually quite similar or related to mixture problems, which we will discuss after this. The guiding principle here is that the fact that the sum of the values of each denomination is equal to the total amount of coins. So, alright, let's tackle an example here. So we have a coin purse containing 5, 10, and 25-cent coins. The number of 10-cent coins is 3 times as many as the 5-cent coins. And the 25-cent coins is 2 more than the 10-cent coins. If the total value of the contents is 4.9 pesos, how many of each kind of coins are in the purse? Now to solve this, let's let x be equal to the number of 5-cent coins. And so it says here from the second statement, the number of 10-cent coins is 3 times as many as the 5-cent coins. So 3x would be the number of 10-cent coins. And then we have the number of 25-cent coins, which from the statement is 25-cent coins is 2 more than the 10-cent coins. So we have 3x, which is the 10-cent coin, plus 2. So that is our 25-cent coins. Now, the equation would be based on the value of the 5-cent coin plus the value of the 10-cent coin plus the value of the 25-cent coin, which would be equal to 4.9 pesos. Right, so writing that down, so we have here 0.05, which is 5 cents, times the number of 5 cents, plus 0.10, which is the value of the 10-cent coin, times the amount of the 10-cent coin, which is 3x, plus the value of the 25-cent coin, which is 0.25, times the amount of the 25-cent coin, which is 3x plus 2. And that should be equal to 4.9 pesos. Alright. So solving for x, we get an x value of 4, which would be the number of 5-cent coins. Right? So let me write it down here. So let's see. Number of 5-cent coin, number of 10-cent coin, and number of 25-cent coin. So let's just summarize it here. So for the number of 5-cent coin, we have x, which is 4. And then the number of 10-cent coin, which is 3 times 4. And that is equal to 12. And then the number of 25-cent coin, which is 3 times 4 plus 2, which is equal to 14. And that would be the final answer for our example. Alright? So on to our mixture problems. So the key point in mixture problems is in terms of their component parts. Yeah. To understand this better, let's try and solve this problem. So 40 liters of a 60% salt solution are reduced to a 45% solution. Now, how much solution must be drained off and replaced with distilled water so that the resulting solution contains only 45% solution? So for the solution, we're going to let X be the number of liters of salt solution to be drained off and replaced with distilled water. The content of the the content of the mixture is given in the following diagram. Alright, so initially, what we have is this one. So you have a 60% salt and 40% water for the 40 liters of a 60% salt solution. So this is 40 liters. Then we're going to subtract a certain number of liters of from the 40 liters of the 60% salt solution. So we're going to subtract X number of liters. And then we're going to replace it with distilled water of the same amount. So that is X liters as well. I forgot the S. And it should be equal to the same amount. So that's still 40 liters. The equation is either based on the salt or water solution. So let's try first based on salt solution. So from that, the equation would be, so you have 60% times 40 minus 60% times x plus 0% times x, and it should be equal to 45% times 40. Now solving for x, it would be 10 liters. Or we could try it another way. So we could try it based on the water solution. So we have, or rather, yeah, based on the water solution. So we have 40% times 40 liters. So 40% of the water times 40 liters minus 40% of water times x liters plus 100% of water times x liters, and it should be equal to 55% water times 40 liters. Again, we're just going to solve for x, and it should be equal to 10 liters as well. Alright, so that's the final answer for our example for mixture problems. Alright, so our next type of problem is motion problems. So you could use algebra for this one, or your calculus from what we've taught in dynamics of rigid bodies. But basically, ito yung concepts natin for motion problems. So a body is moving in a path of constant speed if that body passes over equal distances in any two equal intervals of time. Such motion is referred to as uniform motion in a path. So for example, if you have a V average of 50 miles per hour, your distance traveled for 2 hours would be 100 miles, right? Or rather, in 2 hours. Now, the speed of rate of the body in its path is defined as the distance traveled in 1 unit of time. If r is the rate and d is the distance traveled in t units of time, then you'd get distance is equals to the rate times the time, or d is equals to r times t, right? From this equation, we can derive the associated relationships such as this one. So our rate should be equal to d over t, and our unit of time, or t, would be equal to d over r. Now let's solve some example. So we have your Jen that boarded a bus bound for Baguio at exactly 4 a.m. After 1.5 hours, her husband Ben followed, driving the family car at 75 miles per hour. Assuming that the bus was traveling at an average speed of 50 miles per hour, at what time would Ben's car overtake the bus? So to solve this, we're going to let x be the number of hours required for the car to overtake the bus, and x plus 1.5 be the number of hours traveled by the bus before overtaking. This came from the statement that Jen left earlier than Ben, right? It says here that after 1.5 hours. So 1.5 hours have passed before Ben started the travel. That's where 1.5 came from. And then to further simplify this, we're going to use a table to summarize what is given in the problem. So for the rates, or the speed upon which the vehicles are traveling. So for the car, we have 70 miles per hour, and for the bus, we have 50 miles per hour. And the amount of time they are traveling. So for the car, it has been traveling for X number of hours, while the bus is traveling for x plus 1.5 hours. Now, from our discussion earlier, distance is just rate times time, right? So for the distance that the car have traveled, it's just 75 times x, while the bus have traveled 50 times x times 1.5. Right, so solving for x. So after x number of hours, let's see, let's write it down here. So after x hours, the distance of the car, so let's denote that as c, dc, is equals to the distance traveled by the bus, right? So we can now equate these distances. So we have 75x should be equal to 50 times x plus 1.5. So solving for x, we would get 3 hours. So if Jen boarded at 4 a.m., so after 1.5 hours, which is at 5:30 a.m., Ben left, right? Then the car will overtake the bus at 8:30 a.m. Right? So 5:30. So Ben left at 5:30 a.m. You add another 3 hours to that, you'd get 8:30 a.m. So we have here, so overtaken, how do you write this? The car will overtake the bus at 8:30 a.m. Alright, so that's the final answer for our example. So the next type of word problem we're going to tackle is work problems. So work problems are generally involve the portion or generally involves the portion of a job that a person can do in a certain or a given amount of time. Fractions play an important role in this type of problems. Work problems are similar to motion problems since they involve some sort of rate, right? So the guiding principle in work problems is that is the fact that the product of the rate of work by the number of units of time involved is equal to the fraction amount of the work done. That is, the rate of work would be equal to the amount of work done divided by actual time to finish the work, or the amount of work done equals to the rate of work multiplied by the actual time to finish the work. Often the problem involves 2 or more workers. Say you have worker A and worker B, and each having different rates of work to combine their efforts to complete a certain type of job. In such cases, the basic equivalence relationship would be the amount of work done by A plus the amount of work done by B is equals to the amount of work done together. So you have work done together. So that's the basic premise of your work problems. Now, to understand this better, as usual, let's try to solve a problem. So June can finish an accounting work in 8 hours, while Leo can finish the same amount in 6 hours. After 2 hours of working together, June left Leo for lunch and Leo finished the job. Now, how long does it take Leo to finish the job? So to solve this problem, let's summarize what we know in a table. Alright, so we have our table. Now let x be the number of hours it took Leo to finish the job. So let's fill up our table. So from our problem, it says here that June can finish an accounting work in 8 hours. So June, time to finish work, it would be 8 hours. 8 hours. And then Leo can finish the same work in 6 hours. So we have 6 hours here. Now the work finished in 1 hour would be 1 over 8 for June and 1 over 6 for Leo. Now, each work for 2 hours, right? As says here in the problem. So after 2 hours of working, so in that time, each two did the fractional part of their work. For June, that is 2 times 1 over 8. And for Leo, that is 1 or 2 times 1 over 6. Right? And then June left and only Leo worked and finished the job in X number of hours. So he did X times 6 of the job, or X times 1 over 6 of the job. While June could have done it, if June worked, he would have done X times 1 over 8, right? So when the job is completed, all the fractional parts of the job must sum up to one complete work, right? So the equation would be, so them working for 2 hours, so that's 2 times 1 over 8 plus 2 times 1 over 6. And then Leo worked for an X number of hours to finish it. So that is X times 1 over 6, right? And that should be equal to 1 complete work, or complete work. Alright, so upon solving, our X would now be equal to 2.5 hours. So that would be the number of hours that it would take Leo to finish the work alone. Alright, so that would be our final answer for this type of, or for our example. Alright, so the last type of word problem that we will discuss in this video would be age problems. So this type of problem is usually related to ages ranging between two persons. You would often encounter words like ago, which would mean previous years. Or, on the other hand, you'd encounter words like X years, hence, or X years from now, or in X years, which would all refer to X years in the future. Alright. So, the main principle in here is the difference between the ages of two persons would be constant. To understand this better, let's try and solve some problems. So we have here example number 1. So Lita is 41 years old and her daughter is 9. In how many years will the mother be 3 times as old as her daughter? So to solve this problem, we are going to let X be the required number of years. And then from the problem itself, the age of the daughter in X years would be 9 plus X. daughter's age in X years. And then for the mother's age, it would be 41 plus X. So this is our mother's age in X years. Now, the equation would be based on the mother's age in X years, which would be 41 plus X. And it should be equal to, stated in the problem, 3 times as old as her daughter. So that's 3 times the daughter's age in X years, which would be 9 plus X, right? So, solving for X, our X would now be 7 years. So that is our final answer. So in 7 years, our daughter would be 3 times as old, or our mother would be 3 times as old as her daughter. Alright, so our second problem. Bill is now 24 years old and Charlie is 12. Now, how many years ago was Bill's age twice the age of Charlie? Right, so to solve this problem, we're going to let X be the unknown number of years ago. So this would be unknown number of years ago. While Bill's age would be 24 minus H, or minus X. So Bill's age, wait lang, let's write this better. So Bill's age X years ago, while Charlie's age would be 12 minus X. So this would be Charlie's. Now, how many years ago was Bill's age twice the age of Charlie? So to write this down, so Bill's age years ago, 24 minus X. And it should be 3 times the age of Charlie, which is 3 times 12 minus X, right? Now solving for X, we'd get 6 years. Right? So checking. So 6 years ago, Bill's age would be 18. And Charlie's age would be 6. So we can now confirm. So 18 is 3 times 6, right? So it would be 6 years ago. Right? So that's the final answer for example number 2. And this problem also concludes this video. So with regards to progressions and worded problems. Alright. So thank you.